Hey guys, welcome back to my YouTube channel. So last class we have discussed main thing on how the forward bias things will work. So I think that is very good understood for you guys. So let me revise it. So in this case, the depletion region, the many number of holes will come and replace the donor acceptor atom or donor atom, and then it will slowly reduce the depletion region. And then majority of holes will be migrated from P region to N region, and then that will be recombined in the N region to become minority charge carrier. You need to know that holes will be moving from P to N, and then it will recombine. This recombine is only the recombination which is happening, right? So this is only will make use of our application. For an example, in LED we know, right, the light is blinking, right? So that is because of this recombination that is happening. So these are some application that are I used widely in everything. Like in even in amplifier, similar kind of things will happen in BJT. So I will explain that later. So that recombination will happen in order to make the, because many number of holes will go from this region to this region. But here if you see, holes need to be minority charge carrier. So that will be recombining with incoming electrons as well as free carriers that is present in N region. So this is how the forward bias or our necessary application will work. The same thing in the reverse bias region, the same. Here if you see, we are reverse the polarity. The negative is connected to P and positive is connected to N. Now you see, more number of electrons will be pumped to this region, and here the holes will be recombined with this electron. So it will what will happen? Then further the depletion region will increase. So here more number of holes will be moving from the positive terminal into the N region. So it will further neutralize or recombine many of the electrons present in the N region. So the depletion region will further increases. So then what will happen? Further the depletion region will be going increasing keep on. So there will be no diffusion of charge carrier from this region to this region. That will be failed. So the INET will not be moved. But this is not an ideal device. So definitely there will be some kind of small carrier diffusion charges that will be traversing from one region to another region. So that we will call as a some negligible leakage current or reverse bias current. So let me plot that graph here. So if we draw it, some negligible current will flow in the reverse direction. So that we will call as a reverse bias current or leakage current. So that will be based upon the things. So that is for V and I. So if in forward bias it will go in this region, like this way it will go, but in a reverse bias region, this is forward bias, but this is reverse bias. So in reverse bias that will flow in this region, that will be constant, that will not be increasing further also, and this will be the unit that will flow it's some microamps, very small current only, but here it will flow in some milliamps. So there will be some 1000 times difference between both the thing. So that we may not need to worry. So the depletion region will be further increasing. So the I net current will not be moving because there is no diffusion or drift of the charge carriers between the both the region. So this is how the things will work. So I hope reverse bias, forward bias both are understood by you guys. So now let's see the how the PN junction in energy band is getting changed. So how we in semiconductor we discuss about the energy band, right? So let's discuss that thing also here. So before joining both the thing, like P region is separately there and N region is separate. Before joining both the two separate things are there means, then how the carrier level or energy band, how it will look like. So this is ECEV that you guys know. This is P type region, right? So EFP, Fermi level of P type, here Fermi level of N type. Okay, so this is how. So let me name the things. So this is EC, this is EC, this is EFP. Okay, so this is EFN, this is EB, and this is EB. Okay, the net change between these two will be QV naught. So this much amount of potential which will be needed in order to make this as a conducting material. Okay, so if we combine both the material without at equilibrium, if we combine both the junction, then what will happen is that this is in a P type. The Fermi level will be combined. Fermi level will be joined. Fermi level. This is by combining both the thing, we will be represent that as a EF. This EFP and EFAN both will be joined together because this will be combined. So when two junctions are combined, it will be combined. So here you see this is going up, this is coming down. So this will be coming down. So let me represent the EC here. Like slightly got decreased. There is why got decreased is that because this is matched. So here there is difference, right? So this is coming down and this is going down. So this have come down, it's got little up. So that's why we are representing like this one. So this is EV. Then here it is EV of the N type. So thing is that it is P type and this is N type. So this is P type and this is N type. And both are combined. This is how. So this is how the variation will be. So you can clearly see there will be some kind of voltage difference, that is Q V naught, because this is at equilibrium. So no external supply is done, right? So still the charge carriers need to climb from here to here. If you see many number of holes will be here, these holes need to jump to here. So then only there will be movement of current. Okay, this difference at equilibrium. So I net will be equal to 0. So there will be no current movement. So because it need to jump here, the electrons will be there, right? It need to jump to this side. So here also there will be quite difference of Q V naught. Why we are representing as a Q V naught is this is charge potential, charge carrier diagram. So that's why this is energy diagram. So that's why we are making this a EV. So this is E, this is V. So we are representing this as EV. So that's why QV naught. Okay, I hope you guys able to understand, right? So it's need to jump from here to here. So this much of barrier potential is there, or the difference is there. So if we apply the external potential, then what will happen? This energy level will go up if it is forward bias. This energy level will further go down if it is reverse bias. Okay, so from the previous diagram I make it. So let me draw over this one. So if we applying the forward potential, then what will happen? Eventually this diagram will be jump to this side. Okay, so in this diagram, this one here also, the potential will be somewhat reduced, so that what will happen, the energy can quickly go up. So this difference here, you see this difference I am drawing here. So this difference will be become V naught minus Vf, because this is a forward potential. If forward potential is greater than 0, then the energy band, the depletion region, or the energy band will be decreasing. If forward potential is less than 0, then what will happen? The energy band or the energy barrier between those things will increases. Okay, so that is what the quite difference between forward bias and reverse bias. I have made this both in a same diagram. So let me use a green color, blue color for the making for the reverse bias. Reverse bias, what will happen? It will further decrease. This is for reverse bias. So if it is reverse bias, then that will further decrease. Okay, so here what will happen? Q V naught minus or plus V R. We can make it plus because that will be already always it will be negative. So we can even make it negative or modulus of this one. So anything is fine. Okay, so that will further decrease it. So then it will be more difficult for the electrons to jump. So there will be no I will be equal to 0. But here if you see, the current may be movement. So current will move. Here the red color, which is for forward bias, and the blue color is for reverse bias. So I hope it is understood for you guys. So I have made a single diagram so that you can easily grasp the concept. So let me re-go it. So this is how the normal presented energy diagram presented here. So when they both are combined, this energy level will be matched to this one. So this will become at the same level like this one. So it will be become same level. But this case, this EC and EV will not be matched. So that will be just tilted based upon this moment. For an example, if it is comes down, then this also comes down. It will stay at the same level. If it is goes up, it goes up. So like that difference, the Q V naught difference here is 0, but here that become as a value. So in order to make the electrons or holes from jump to this region, we saw, right? So these holes need to jump from here to here, and this electron need to jump from here to here. Then only there will be current movement. So in order to make that happen, we need to reduce the QV naught. QV naught is the potential or the energy difference or the del E. So once that becomes approximately equal to 0, then only conduction will increases. So the conductivity will increases. If it is increases, then conductivity will decreases. So in forward bias, what will happen? The difference will be close to 0, but in reverse bias, that will be keep on increasing. So the conductivity will decrease. So this is what the simple analogy of the things that are present in the reverse bias and forward bias, in based upon the energy band diagram. So I hope it will be understood for you guys. So in this lecture, we saw about the reverse bias as well as the energy gap diagram for both forward bias and reverse bias. So I made all things in the single zone. The red is for forward bias and the blue is for reverse bias. The white is normal region. Okay. So please clearly understand it and make a note of it. So I hope it is understood for you guys. Thank you. Stay tuned, guys.